Hi everyone, welcome back. This is the 52nd video in our series on building a chess engine from scratch in the Java programming language. In this video, I want to introduce the FEN file format, which is just a standard notation for describing a particular board position in the game of chess. This is really useful for when you want to analyze a game in any position and without having to play out all of the moves that took place in that game, right? So let's quickly look at the definition for the FEN file format. I'd like for you guys to read this offline. I don't want to spend too much time in the video talking about it because the information is freely available on Wikipedia, and I'll have a link in the description box. But basically, I think we can really understand it quickly by looking at an example. So here's the opening standard position for a game of chess, right? Notice that that there are pieces that have a lowercase and an uppercase. So white's pieces are designated in uppercase, black's pieces are designated in lowercase, right? So rook, knight, bishop, queen, king, bishop, knight, rook, and p for pawn, obviously. And then you can see we have 8 open slots, /8 open slots, /8 open slots. I think you sort of get the idea. And you can look at an example that's not exactly like that, right? So like here, it looks like black's pieces haven't moved, but white's pieces have moved, right? So 4 open slots, then a pawn, then 3 open slots. So the board is represented by this string here, and then there's the designation of whose turn it is to move in this position, white or black, right? In the opening position, it's white, and then there's information about what legal castles remain. So there's still a legal kingside castle for white, and a legal queenside castle for white, and a legal kingside castle for black, and a legal queenside castle for black. The next square is a designation for the en passant pawn. There is no en passant pawn on this current board. And then the last 2 slots have to do with the game clock and the move number. And you'll see in our implementation, we'll ignore those. We'll just hard code those values because our chess engine doesn't really have any clock information, and I don't want to introduce any more complexity than there has to be. So with this information, let's go and start by introducing our API, okay? So I want to come in here and, so we have com chess, either engine and GUI, and I want to actually introduce one new package under chess called new package called I want to call this pgn. Okay. New Java class, and we're going to create a utility class called FEN utilities. Right, and let's start by defining the constructor. We're going to actually say that this is not instantiable. It's going to be a singleton, if you will. Private FEN utilities, throw new runtime exception, instantiable. Okay. And there's really going to be 2 methods on here that are going to be publicly visible. Okay? Public static board create game from FEN, final string FEN string. Let's return null for now. And public static board parse FEN. So this is the exact opposite. This actually takes a board. Create game from FEN takes a FEN string, and this actually, I'm sorry, this returns a string. Parse or create FEN from game. Sorry about that. So we're going to give board. There we go. Let's return null here too. So given a FEN string, return the board, and given a board, get its FEN string. These are the two public API methods that will be interesting for us to define. Okay, so let's start with the method that takes a board and converts it to its respective FEN string. So if we were playing on the initial board, we would return this string right here. That's what our unit test could look like. You could make sure that the string for the FEN string for the initial board looks exactly like that. So what we're going to do is, ideally we would say that this method would call calculate board text. You'll see how I'm going to break this out. For a board plus a space plus calculate current player text, a given board plus a space, and then calculate the castle text for a given board plus a space, right? Calculate the en passant square for a given board plus a space. And lastly, we could write a method for the half clock and the full moves, or we could just return 0 and 1, because as I mentioned at the beginning of the video, we're not going to solve this problem. It's not really relevant to our engine. You can solve it. You can choose to do this as an extra credit assignment if you like, but it's really not that big of a deal. So notice that I've just written methods that individually map to the different sections of the FEN file format, right? And we're just going to incrementally knock off each one of these methods. Alright, so let's warm up by writing one of the simpler methods, calculate current player text. This should be really easy to calculate. And so actually want to return this method to return a string. So calculate current player text given a board. What I'm going to say here is return the board, current player, to string it, and we're going to use the substring on the string method to return the first character of either white or black, and we're just going to invoke two lowercase. And that's it. So really, if you look at the FEN file format, again, the white or black player, the current player, is shown the active color. W means white to move, B means black to move. So we just finished that method. Next, let's look at the calculate castle text method. And here what we're going to say is, let's generate this method too. All right. And let's say final string builder, a new string builder. All right, and we're going to say if board white player is king side castle capable, we have to write this method, it doesn't exist right now, then builder.append k, right? Then we're going to say, we're going to have the exact same condition only is queen side castle capable. Return, and we're going to append a Q, not return, excuse me. And now we're going to do the exact same thing for black, right? It's a black player. And for black, we're going to use lowercase k and lowercase q. And finally, we'll say final string result equals builder dot toString, and return result dot is empty, question mark, then blank, otherwise result. Right? So if you study the FEN file format, this would make sense. This is really saying that there aren't, if no castles are available on the entire board, then we just sort of put a dash, like this. So there's that method. All right, so next let's look at calculate en passant square. So let's generate this method. And so we're going to say final pawn en passant pawn is equal to board dot get en passant pawn. If the en passant pawn is not null, then we're going to do something. Otherwise, we're going to just return dash. And here, if you look at the documentation, en passant target square in algebraic notation. If there's no en passant target square, this is just dash. We've covered that. If a pawn has just made a 2 square move, this is the position behind the pawn. So it's actually not the en passant pawn, it's the position behind the en passant pawn. To determine that, we need to do a little bit of math, but it's actually not that difficult. So what we say here is, we say return board utils dot instance I'm sorry, get position at coordinate en passant pawn dot get piece position with the offset of 8 times the en passant pawn's alliance offset. Get opposite direction, the direction that it's moving in. Okay, so this is just a little bit of math. It's not that scary, but basically all we're saying here is that this is the position, quote unquote, behind the jump pawn that just made the en passant pawn that just made the jump move. Okay, and that's that depends on the direction that you're going in, white or black. So that's what this method does here. Okay, so lastly for this end, we need to calculate the board text. Okay. Oh look, I knew that one was string. Okay, so this one's actually not going to be that difficult. So we say final string builder is equal to new string builder, and for int I equals 0, I less than board utils dot num tiles I plus plus final string tile text equals board dot get tile I dot toString builder dot append tile text. Okay, so first basically just go in and get the tile text for build the board up as a string, right? That's the first thing that we're going to do. And then we're going to insert at certain positions the hyphen builder dot insert insert at 8 a slash. Okay, and we're going to do this a few times all throughout the board at position 8, at position 17, 26, 35. These are at each of the edges for each row. 44, 53, and 62, right? And we're going to say return builder dot toString dot replace all and we're going to use this trick here. Let's say 8. If you have 8 dashes, 1, 2, 3, 4, 5, 6, 7, 8, you're going to replace it with the number 8. Okay. And we're going to say, oops, I actually prefer doing it back here. It's a little bit more readable. If you have 7 dashes, then replace it with the number 7. I wish IntelliJ were a little bit smarter than this. Replace all. If you have 6 dashes, I believe that's 6. 1, 2, 3, 4, 5, 6. Replace it with the number 6. And we're just literally following the convention for FEN. Place all 5 dashes with the number, with the string literal 5, not the number 5, sorry. I gotta make that change here. And so on all the way down to 1. So dot replace all. Oh boy, this is tedious. Dot replace all. Dot replace all. Last one, dot replace all. Right? And this is in keeping with the definition that's given to us here, right? So if you read through this, what you'll find is that you basically want to replace the dashes with the number that you have here, right? So if we had 8 dashes, we would literally replace it with the number 8. If we had 2 dashes, we would replace it with the number 2, right? So yeah, that is it for this. And next we have to define these 4 methods. Okay, so on the player class, what we're going to do is this. We're going to go to the player class, and we're going to introduce the methods called is kingside castle capable and is queenside castle capable. Okay? And we're going to make these methods public. Public boolean is kingside castle capable. Let's just return false for a second. And public boolean is queenside castle capable. And by doing so, that should resolve that resolves all of our compile errors there. Now it's just a matter of defining these, and we're going to delegate to the player king piece. We're going to say this dot player king dot is king side castle capable. Just move my problem down one level. And this dot player king dot is queen side castle capable. You'll see how we solve this. Basically, when I construct a board, I'm going to tell the king that when I construct a board, I'm going to construct the king. And when I construct the king piece, I'm going to pass an argument to that constructor that tells us whether it is or is not king side castle capable and queen side castle capable, respectively. Right? So we can go here to the king, right? And let's go to the king piece. And let's return some public methods on here. Let's say public boolean is king side castle capable. Return false. Public boolean is queen side castle capable. Return false again. That should solve my compiler errors back here. It does. Right. And now we're going to return some, we're going to have some state on here. Private final boolean king side castle capable. Private final boolean queen side castle capable. Okay? Alright, and actually let's keep track of one more thing, which is private final boolean is castled. Right? Okay. So now that we have those things, let's just make getters for all three of these. Public boolean is castled. Return this dot is castled. Return this dot is king side castle capable. Oops. Somehow. Okay. And this dot is queen. This dot queen side castle capable. Okay. So now we have these getter methods, but they just aren't returning the right value. And so we need to make sure that we set them accordingly. So let's update this first constructor first. And we're going to pass in, along with the piece position, we're going to say final boolean king side castle capable, final boolean queen side castle capable. This dot king side castle capable is equal to king side castle capable, and this dot queen side castle capable is equal to queen side castle capable. Great. And this other constructor is taking in, we're going to pass in, after is first move, we're going to say final, oh, let's pass into this, for this one, we know this dot is castled is going to be equal to false. Okay, so I'll come back to that. Final boolean is first move. After is first move, we're going to say is castled. Final boolean king side castle capable. Final boolean queen side castle capable. And we're going to say this dot is castled is equal to is castled. This dot king side castle capable is equal to king side castle capable. This dot queen side castle capable is equal to queen side castle capable. Okay, so now we've got all of that state propagating through. The only problem is where we invoke our constructors right now, we're not using the right signature. So if we try to run our program, we should actually find what all of those places are. Let's see if we can quickly do that. right? And we're seeing that there's a problem in move piece. Okay, so notice we're on move piece for the king. And here's what makes this really easy. So when we move a king, right, if we look at the signature on this method, when we move a king, we know exactly what it's going to look like. It's going to be false moved, and I'll explain this in a second, is castling move. Let's put some brakes on this here real quick. Right. False and false. So if we, that's what makes this really simple. If you go and click into this constructor, you can actually validate this for yourself. If you're moving the king, you know these two are going to be false because you're no longer castle capable after you move the king, right? You know that. No longer castle capable. Then the next question that you're asking is, am I castled? And that question can be answered by going, well, was the move I just made a castling move? Yes or no? And is this the first move? Obviously not. The king is now just moved by definition, so we can pass false into this argument as well, right? So that really should be it. Let's see. Okay, so now we have to go back and update, create standard legal move on a board, right? So, which shouldn't be too difficult, right? We want to be able to say for a given board, and we're going to use the other constructor here. We're going to pass in true and true there, and here we're going to pass in true and true. So here all we're using the other constructor to say that by definition on a standard legal board, you can castle your king, right? And you can castle your queen. Okay, so let's run it one more time. Okay, great. So now this compiled. So in the next video, I'm going to focus on the opposite method, where we are given the string, I believe, and we want to, right, so what I focused on building out was, given a board, return the string. In the next video, we will say, given a FEN string, return the corresponding game board. So thanks everyone. Please make sure to like and subscribe. And I haven't made a video in quite some time. I'm going to try to get back on track and make more videos for you guys. And as I promised before, I am working on some material beyond chess as we come to closing this playlist out pretty soon. One of the last chapter that we're really going to work on after this is game databases, and we'll see how far we get into it. I don't want to make too many videos in this playlist for it to be too intimidating, but thank you guys for your interest. I appreciate it, and I'll see you guys soon.